Okay, so this is today's project. This is an oscilloscope that I just picked up at a estate sale for about $10 because really cheap because it was sold as non-working. Said on the top from the seller that it has beam, but it has no sweep, so at least that should mean we have a good CRT in it. So we're going to try to troubleshoot this and get this to work again, because it's always good to have an extra scope in case my other one craps out. Really useful things to have. Okay, so I got it plugged in. I'm going to put you guys on a tripod. So what we're going to do is we're just going to see what it does. Heard a popping noise. Okay, that's a bit bright. Okay, that's bright. Oh, okay. It might have just been in XY mode. Oh, no, something's wrong. So, if I move the horizontal position right here, it just stops right there. So there's something wrong with either the sweep or the deflection board. Okay, so I don't think there's anything we can do from the outside, so I'm going to go ahead and open it up. Okay, so really cool thing about test equipment like these, it's meant to be serviced. See if I can do this one-handed. Look at that! You can just take this whole thing out without even opening it. That's pretty incredible. I'm still going to take the covers off, though. I just thought that was cool. Okay, so another weird thing I just found out. These aren't normal screws. They only rotate like a quarter turn. Okay, so I think it's like a clamshell type thing. You just take these bars off, and then this top half and the bottom half should just come right off. Oh, I'd say that's pretty. Look at that. That looks very American made. Must be those driver's transistors right there. Okay, let's look at the other side. Okay, not much to see over here. Geez, 18,000 volts. That's pretty high for an oscilloscope. Should have a pretty nice trace on it. Cool little arrow. those are some pretty big caps. Like some regulator transistors. That's pretty cool. It's a 2N3055 for one of their power regulators. Pretty crappy transistor. Here's that module that you could just pull out right here. Connector. So look at the other side. Okay, so I think there's a fuse panel in the back. I think I'll check those first. Okay, so I got 4 fuses there. Okay, so those look good. So I guess we just have to take a look at the horizontal deflection board and see if there's anything obvious on there. Okay, so this is the horizontal amplifier board right here. And here are the horizontal deflection transistors. And right there, that definitely looks like it could be an issue. I can't really tell the value of that resistor, but I'll try to measure it and see if I can get anything on it. I mean, just because it looks that way doesn't mean it's bad, but it's definitely an indication that it's seen some use. God, look at the crack in that even. That's pretty bad. So I'm going to measure that and see if it measures anything. Gotta make sure you pierce any. Okay, so that's saying 800K. That I have to figure out what resistor that is, but that sure looks like could be an open. Okay, so in the other polarity, it's infinity, so that could be like a transistor junction that we are reading right there. Yeah, 800K. And open. Okay, so I'm going to have to try to find a schematic for this and figure out what value resistor that is. Maybe if I unsolder it, I'll be able to sort of read it, but I'm not sure because it's pretty burnt. Okay, so if you look right here on the board, that's labeled Q10 right there. That's labeled Q9. The bottom basing of these transistors, this little notch right here, that's the emitter. The one in the middle is the base, and this outer one is the collector. So this resistor right here goes from the base of Q10 over to the emitter of Q9. I printed off the schematic right here. Here's Q9 and Q10. So you see the emitter in this case is grounded. So, and here's the base of Q10. And we see from the base to ground, or from the base to the emitter of that one, we have a 22.1K resistor. And I can faintly see the bands, but they're not very visible. This one I can read. That's a 22.1K, but this one I can't. So I'm going to look through my 22K bin of resistors and try to find one that has drifted up to an extent that's about 22.1K. Not that it will really matter, but it's nice to try to get it close. Damn, metal film resistors are always correct. Here's a carbon one. No, that's low. Here's another metal film. That's too high. It's too high. Boring video. Is that one open? Okay, I'm just gonna find a resistor and put it in there. I found a resistor that was pretty close. It's about 22.15K. I'm not going to be too worried about that. And for now, I'm just going to tack it in to see if it makes a difference or not. I don't want to solder it in all pretty and then find out that it doesn't work. Whoopsie. Okay, so I have it plugged in, and now I'm going to watch it explode. I kind of don't like that crackling sound. Uh-oh. Ooh. That looks like it's working. Gonna do a ghetto test. Okay, I don't see any response from the amplifiers. Should be able to see something on the display. I'm not getting anything. Okay, now what did I screw up? That doesn't sound good. Okay, I'm going to play with this and see if I can get some vertical deflection. Okay, so we had a bit of operator error there. I had the switch here set to ground reference. Oh wow, that's just the noise from that resistor. Wow. That's crazy. I'll admit, I'm not used to this particular scope. Okay, so channel B. Huh. Okay, so I think there's something wrong with channel A. Do you see how that trace looks? How it's flat? See how that's kind of curvy? So there's some kind of interference or something. That looks like 60 hertz bleeding in somewhere. Yeah, that's 60 hertz. So we go to 50 ohm termination, or okay, even ground, that's. So there's something wrong with that channel right there. I'm not sure what. And there's that. Sounds like there's a high voltage capacitor shorting or something in there. Oh, that could be a heater to cathode short. Uh-oh. Yeah, this has got some issues still. Yeah, that's not the best, is it? Oh, that's cool. Has a light. Okay, so let's go to... I want to see if I can adjust the astigmatism. And I'm going to burn a spot right in there. Nope, that was That was about right. Nope, I just have to live with it being slightly out of focus, I guess. Yeah, there's something a bit funny with this. Okay, so let's just do both channels at once. So this seems like similar functionality to my other oscilloscope. Just a little bit more messed up. Okay, so I'm gonna solder that resistor more permanent in there and see if we can work on some of these other issues. Why won't you focus? Why are you doing that? Okay, I got the new resistor in there. Looking good beside the hum in that channel. Don't know what else to call it. I think that would require some extensive troubleshooting that I'm not quite ready to do right now. So I think I might just button this back up for now. Okay, so just one last shot of it all put together. It's pretty cool. It's so sensitive. That's the noise picked up from those two resistors. Here's just a quick shot of it with the calibrator. I mean, the one thing is that this trace is not quite aligned, but I do not care, to be quite honest, as long as it works. Okay, so a little addendum to that video. I've had this scope running for just a while to make sure nothing blew up or anything, and the longer it ran, the ripples in that channel have gotten less and less. So now it looks pretty good. You can still see a tiny little bit, but it seems like a thing that's just going to get better as it runs, so I wonder if there's some capacitors in there that are reforming. So this scope looks pretty good.